Good evening everyone, I am Nazmul PL here. Welcome to today's ArcGIS tutorial. This is a series of tutorial and this is its fourth edition. In today's tutorial we'll be converting projected coordinate system to geographic coordinate system, exporting ArcMAP layer to KML file, georeference satellite image. Okay. At first, let's see what is a projected coordinate system. A projected coordinate system is when you have converted a three-dimensional projection system into a two-planar surface. That means when you draw everything over a ball, a round ball, and then you place everything in onto a paper. So that will convert your sphere to a paper, and that is projection. If you have come this far, you have already known what these are. Just for further clarification, check on Google and you can see everything. So basically a projected coordinate system is a two-dimensional coordinate system, and a geographic coordinate system is a three-dimensional coordinate system. As you can see, the very first line, it is defined. Okay, so let's get to work, and we have opened our first ArcGIS file. So this is our ArcMap view. In our previous tutorial we have shown you how to georeference a image or map like this. This is a very basic map. This has been drawn by hand, though some projection system was maintained when this map was drawn, and later we have shown you how to digitize a map like this one. If we activate this layer, as you can see, this is a digitized file, though I have not completely done it. Okay, what we'll be doing is we will be converting this polygon, which is a shape file, to WGS84. That means we will be converting this projected coordinate system based Choto Baraid shapefile to geographic coordinate system based shapefile, which will be WGS84. So let's not waste our time and start converting. First, what I have to show you is go to data management tools and go to our projection and transformation, and now I have some custom geographic transformation defined in my computer. If you are from such countries like USA or UK, then your custom geographic transformation will be already added in ArcGIS. But if you are not, like in my case, I'm from Bangladesh and my projection system is not done really. So what I have to do, I have to create a custom geographic transformation. So double click on it and a new window will pop up. Okay, give it any name. Suppose what I'm doing here is I'll be converting BTM to WGS84. Okay, let's not leave this space in here. Okay, what will be my input geographic coordinate system? My input geographic coordinate system will be BTM. Okay. Okay, which what is showing is this geo transformation file already exists. That means I have done it earlier. And my output geographic coordinate system will be GCS WGS 1984. Then just press OK. Now you have your custom geographic transformation, and then what you have to do, you have to project this. So make sure you have previously clicked on this polygon and then double click on project. Okay, so what my input layer will be, my input layer obviously Choto Baraid underscore polygon, because this is the shape file. polygon based shapefile. And then as you can see, input coordinate system is by default BTM. Why is that? That's because if you remember, my dataset was, my main map was in BTM. So when we digitized on it, that was also BTM. So when I am trying to convert this, it is already showing that this has BTM as its projection system. Now what my output coordinate system will be? So my output coordinate system will be WGS 1984. Press OK. If you have successfully done this step, then as you can see, there is a thing shown BTM to WGS 84. Okay, now a thing in here, my output file, what do you want to do with this? If you want to, if you need a temporary converted file, that means you just need it for something and then you don't need it later, then you don't need to change this. You can see this thing, you don't need to change this. But suppose you need this for later and for some other purpose, then click on this, and this is my folder. Here I will save this as converted to WGS 84, then press save, and now you will get a file which won't be added in your layers, but it will be saved in some in your desired location. Now press OK. So as you can see, this projection is showing completed, and then close it, and then close it too. Now you have a geographic coordinate system based this polygon saved in your PC. Then go to add data, and then go to your folder where you saved it. Then this is my file converted to wgs84.shp, and then just add this file. It is showing that your data source, the file you are importing doesn't match these layers. You don't have to do anything in here, because as you know, my all my things and my layers are in BTM mode, but I have saved this in WGS84. So when I am trying to bring this, this is showing there is a conflict between this file's projection system and your layers or your ArcMap's current projection system. So in this case, I don't need to do anything, but because I just need to convert this, so keep it as it is and then just close it. Okay. As you can see, there is some change. The file we converted doesn't exactly match with our map or our shapefile. Why is that? Because there has been a change of our coordinate system. We have converted 2D into 3D. So there is some change in there, and so the data will not be completely overlapping. Okay, this is just for just checking how close my data is. As you can see, this is pretty close. If this file is not shown in here and this file is very far away from your main map or the polygon, then there you might understand that there is some problem with your file with your coordinate system. And so when you take it to Google Earth, there will be a possible of error. So what I have to do is, now I have to export this layer to into KML file. Okay, just go into Arc Toolbox, go to Conversion Tools, and what is to do, we have to go to KML. So expand to KML and layer to KML. So this will convert my layer into KML. Okay, double click on it, set the layer. This is converted to WGS84 and define the place where you want to save your output file, which will be same as my folder. Give it a name like KML of conv file, then just save it. And layer output scale, always keep it 1, so this will be, there will be no distortion or change in scale. And make sure to check this on, which is clamped features to ground, so it will make sure the projected file, the layer you made, it will always on ground. Then press OK. This is executing, and then close it and go to your folder, and you can see there I have my file KML of converted file. Okay, now go to Google Earth. I recommend using Google Earth Pro version. Then go to File, Open, and just open your file. Now this is taking me to my file. Now as you can see, this has taken me to some place. If you look carefully, this is a match, not 100%, but this is pretty much a match. As you can see, there is a line going and my map is just beside that, and there is some change, there is some river, and my map's edge is all along. There might be some difference, but that's acceptable. Okay, this is the first part of our today's tutorial, which is we have converted successfully a layer into a KML file and opened with Google Earth, and we have placed it on real world. In before, this polygon was over a map and now it is on real location. Now the next job we have to do is we have to take a satellite image from here, from this Google Earth, and we have to take it to ArcMAP, and then we have to georeference it. So let's start doing. I am temporarily hiding my polygon, and what we have to do at first is we have to get a map just from top of it, so there won't be any angular distortion. To do that, click just in this place where I have taken my mouse. Click on it. This will gradually start rotating at a time, and when it has started rotating, then just click on this N letter. Okay, what it means is it has make this image truly vertical. That means you have truly seeing it from above. Okay. Now I have to take an image from here. I have to take a save image actually. If you are not using Google Earth Pro, there will be some problem with your saving, which is you won't be able to save it in high resolution. Okay, I am doing it again. Okay, my map is truly vertical. So this is my window. From here we will take this image actually completely, and then we'll georeference it. But I need to remember what was my screen actually. So I need to do something. Let's draw a polygon in here. Go at polygon and rename it like image area 9427. This is just today's date so that I don't mess up my thing. Okay, drag it inside and then start drawing your polygon. So take your first point at the corner, then one in another corner, then take a corner in your right down corner, and then take another point in the other corner. Okay, you have taken a polygon, or there is some problem. Okay, so this is my image area, but I don't want it to make it white, so I will change it to just outlined with white cover. Okay, so with this polygon I know where my image should be and what is the area within my area is, my shapefile is, and then you will take some point to georeference your map. Now at this point you don't actually need this converted to WGCT4 file. So now within this box, obviously within this box, take some place mark. In Google Earth Pro we call it place mark. So take any place mark at first and then press OK. Okay, I have there's a mistake. Okay, if you click on this folder and then you take your place mark, this place mark will go into this folder. So always be careful where you click before you adding place mark. Okay, then we can actually create a folder called GCP, which is ground control point, and then press OK. We have a folder called GCP under my temporary places, and then clicking on GCP, take your 4 placements, rename it to 1. This is my first. Okay, this is, then press OK. I will now just copy it and paste it 3 times. So I will have 4 control points. Now click on, right click on it and then go to properties. When you go to properties, you will have the liberty to move it. Okay, then we will be moving it into some place which is actually identifiable when later. Zoom on the place, and suppose we have taken our first point in here, but I should not be doing this because I need 4 control points at 4 corner of my rectangle. So let's not take in here, take it to this place in here. Okay, but there is a caution: never ever take your control point beside the river or any place where it can be vanish after some days or after some years. So always take a permanent location. but in my case I don't actually have that much permanent locations, so I'm just taking any point I can actually see. Okay, then press OK, then go to the next and click properties and rename it to 2. So this will be your second control point, and this one I want to set it in here, and there I can see a corner, placing it in here, then press OK. Then I'm just quickly doing this again, then taking it in here, then press OK, go to the last one, rename it to 4, and then take it to some place like this is a building, I guess, and over the building. Okay, and then press OK. Now you have a folder called GCP, and what I have to do now is I have to export these files. So right click on it and go to save places as, go to your folder, and this is already named gcp.kmz. Just keep it like this and press save. Okay, now I have dealt with my GCP, and now let's get back to your image area. Be sure to make your map truly vertical again, because every time you move this changes the direction. So now I have truly make it truly vertical and true north. Then you go to save image option in here. Please make sure you are using Google Earth Pro, otherwise you will not be having any option like this. Okay, now go to map options and uncheck everything, because I don't actually need this things. Scaling is obviously 100%, and now go to resolution and make it maximum, and now click on save image and rename it to satellite image and press save. This will take a while to prepare because I have take it in very high resolution. So my map is saving, and it will take, oh, this has been done. Okay, let's go to my folder and check how the image is. Okay, I have a very large image, almost 5.5 megabytes, and as you can see, this is a pretty much very clear image of our site. Okay, now this is it, and we have got our image. Now what we have to do is we have to georeference this satellite image. Okay, now what we'll be doing is we'll be georeference our satellite image. So the steps now I will show you. This is very complex. I have a layer in here, and these layers doesn't have actually any coordinate system. So we will firstly import the data, import our KML file by adding data. Go to our folder, and as you can see, I can't add my file from here, because when we need to import a KML database. Go into Arc toolbox, then you have to use conversion tool and go to from KML and then KML to layer, which will bring your KML into your layers. Okay, my input KML file will be GCP because I just need the ground control points. Okay, I'm going to GCP and what I have to do is there is an output location on ArcGIS. Do I need to use this file? Actually, I don't need to use this file because what we'll be doing, I will be converting this layer to WGS84 or to BTM actually. So I don't actually need to save it in any place, and it continues. There is an error because I have already written named something GCP. Okay, so GCP April 9. Are you happy now? Okay, then don't need to click this include ground overlay, just press OK. This can take a while. Okay, now what we have here is we have the GCP, which is ground control points. So let's go to points and right click on it, and as you can see the geographic coordinate system is WGS84 and this is the geographic coordinate system. So that means this is in 3D, three-dimensional coordinate system because we have imported this from Google Earth and the Earth surface is round and so this is three-dimensional. So just press OK and go to your layers and check the properties now, and as you can see your current coordinate system is WGS 1984. Why is that? Because in a fresh data set you have brought a WGS84 file, so which turned your your system in layers to WGS84. So we'll be dealing with two different data frame, which now my first one is actually WGS84. So just rename it to WGS84 database or data frame actually, and then create a new data frame by going to insert and data frame and rename this to BTM. Okay, now right click on this and now we have created a different data frame, and right click on it and go to properties and select this BTM and press OK. So now you have two different data frame. So what we have to do is now I have to bring this and take it here, and there will be a warning which is saying there is a conflict because we wanted to make this conflict because we brought a WGS84 data into a BTM projected coordinate system. So there is a conflict and go to transformation. This transformation is called on-the-fly transformation, and this is a very much practical way to convert something into a different coordinate system, because in our previous videos we have used a different method and which is a very cumbersome and very time consuming, and from now on we will be using this. We'll create a different data frame and we'll be just dragging it into it, so we don't have to worry about anything. So the file we'll be converting from is GCS WGS 1984 into GCS Everest Bangladesh. This is shown by default because the only other data frame in here is in GCS Everest Bangladesh, and there is a choice option, which is, in my case, I am doing WGS 84 to BTM, which we have created some moment ago, if you remember. WGS to BTM, and then press OK, and then click OK, and then you can close this. Okay, press zoom to layer. Now you can right click on it and go to properties, and you can see this is actually not in BTM. I have to check my error. So we have brought this into BTM data frame, and if you go to properties, it will be showing WGS default, but don't worry about this, because this is a Onthefly transformation system. This will show its original WGS default, but it will actually act like a BTM. So don't worry about that. And now what you have to do is you have to convert this to a shape file, which is go to data, and then go to export data and export all features. And there is a very important thing: what you want to be the coordinate system, these layers source data or the data frame. If you choose this layer source data, there will be no point of using this method, because you will be having a WGS 84 shapefile, but we don't need that. We actually need our BTM converted file. So go to, just click the data frame and then define the place you want to be, which is my folder, and export output to underscore shape. Okay, let it be this. This is a shape file. Okay, this is the shape file, and then press save, and then click OK. Do you want to add the exported data to the map as a layer? Yes. Okay, now we have our data, export output, and if now we will be adding our georeferencing image, which is the satellite image. So go to add data, and which is set image, and then edit. There will be an unknown special references. Don't worry about that, just press OK. Now we have, what we have to do is we have to georeference this. We don't need to see it now anymore, so unclick this, and then we have to do georeferencing. So you know how to do georeferencing. Go to fit to display. I can see my image actually. So now what you have to do is change the colors, change it to something visible. Okay, now you have to do georeference. So you need to go back to your earth and see what the points were actually. So my first point is this point. So going back to this location and setting my first control point at here, then this. Where is my second control point? I will be going to my fourth control point, because this is directly on the other side. Okay, I cannot see. Okay, this building in here, just top of it. Okay, where is that building? Okay, maybe I need to go again to see where the building was. This building was beside vacant land. Where is the vacant land? Where are you? Okay, this point in here. Okay, this is it, and the point is this one. Okay, if there is no problem, then the other 2 points will be perfectly coincide, and as you can see, this point is showing this point. Let's go back to my arc. Where is my third point? Second point, actually. My second point is just at this corner, so there is actually very little error. Okay, and now the last one, which I believe has perfectly coincide. This is just beside a boat. Okay, this point is a complete perfect match. Okay, then go to your link table. The error is very less. Now you update your reference. Okay, I have finally updated my image with georeference data. Okay, maybe I have done a little error. So we have completed our georeferencing, and this is what my maps look like. Now, why we did this is we actually wanted to see after georeferencing if our shapefile was actually accurate or not. So now we will be just adding our shapefile into this data frame. So as you can see in our image, we don't have to do anything. We just brought our polygon shapefile and it just overlapped on it, just like this on the Google Earth. Same, exactly same as Google Earth. So this is how you can actually make your satellite image georeferenced. So that's all for today. Thank you.